Okay, good morning, good afternoon, depending on where you are. Thank you for joining us for Index on Air, the Future of Robotics. My name is Will Knight, and I'm a senior writer at Wired. We have two excellent guests joining us today to talk about this subject. First is Chris Urmson, who's the co-founder and CEO of Aurora, a self-driving technology company. And before that, of course, Chris famously was the lead on Google's groundbreaking self-driving car project, where he served as CTO, and he has been a veteran of the vehicle AI industry for the last 15 years. Alongside Chris, we have Peter Xi Chen, who is co-founder and CEO of Covariant, a leading AI robotics company. Covariant is building what it calls a universal AI that allows robots to see, reason, and act on the world around them. And before joining or creating Covariant, Peter was a research scientist at OpenAI. Now, I've been asked to remind you that you can ask questions at the bottom of the screen, and we already have a bunch of questions that came in, I think, during registration. So let's get into this very interesting and important topic. I think the first thing to ask both of you is really for a quick overview of what your companies do. So Chris, since you are chronologically closer to me on the screen, why don't you go ahead and tell us what you're up to at Aurora?
Sure. It seems like as good a reason as any. Aurora's a company we founded about 4 years ago with the mission to deliver the benefits of self-driving technology safely, quickly, and broadly. And so what we do is we brought together some of the best people in the industry to help make self-driving cars a reality, and do that in a way where we build the Aurora driver, which is a platform that will enable our partners that make vehicles and our partners that use vehicles to actually build their businesses better and move people and goods through the world safely. So that's what we're about, and we're excited about the progress and really appreciate the chance to chat with you today and be here.
That's great. That's great. Thank you. Peter, why don't you tell us about Covariant? So you're a different kind of robotics proposition in a different industry, but obviously there are a lot of fundamental connections as we'll get into. So yeah, tell us about Covariant.
Yeah, so definitely. There's so much in common with what Chris has talked about. So we're excited to be here, and thanks Index for putting this together, and thanks Will for moderating and paneling for this. And so what Covariant is, we think of ourselves as creating universal AI for industrial robots. So when we think about industrial robots, like those big robot arms, they have existed for decades, and they have served as backbone of a lot of important industries like manufacturing. Like most cars that we drive nowadays are built by robots. So you might ask, like, well, robots are everywhere already. Like, why do we still need to build a new company for it? We would like to think of the existing robots as robots by program. So essentially you program it to do the same thing again and again. But they really lack the intelligence to look at the environment and adapt and change. And what Covariant does is we build that universal AI layer to allow robots to be more intelligent, be more adaptive. And what we mean by universal is it's not just for one particular application, but it's a standard layer that can be used to apply to different applications, different industries. And we similarly are a platform company. So we build this AI as a platform, and we allow our partners to build amazing robot applications on top of it. So which is very similar to what Chris was saying earlier, like that AI driver that allow car vehicles manufacturers or other partners to build their business on top of it. It's similarly in our case. And I think we'll probably go a little bit deeper into those topics. So I will stop here, but excited to be here, and very looking forward to the conversation.
Great, no, that's great. Yeah, I think you make a really great point, Peter. That this is an industry, manufacturing, or I shouldn't say manufacturing because you're more in sort of logistics, but it's an area where there's been automation for some time, and a lot of people may not realize, but the car industry has also had has this incredibly long history of automation, everything from automatic starter, I think, going to sort of driver assistance. So the question, which is important, I think, for our audience is sort of why now, and why in this sort of like the last 5 years or decade or so are we seeing this kind of like fundamental shift, because this really is a really very significant shift in both those areas. So yeah, I mean, Chris, do you want to explain why, what kind of made it possible?
Yeah, I think I think that's really insightful, right? The idea of automation in the automobile is not new. And there's been incremental parts of it, whether it's driver assistance features or the fact that you don't have to hand crank your starter, or automated shifting or automatic shifting, right? So there's been baby steps, but even the idea of the vehicle driving itself is getting on for 100 years old, right? There is this great photo or sketch in Scientific American from 1918 that showed a driverless car, right? So it's not a new idea. So why is it actually becoming viable now? There's a few things. So one is the kind of advances in sensor technology that have trickled down, whether it is the advancements in camera technology that comes through the rapid pace of innovation that's been driven by the cell phone industry, some really exciting breakthrough in LiDAR technology over the last little while, particularly things like the FMCW LiDAR that we're developing at Aurora, advancements in computing and how much power is available on a vehicle today to actually understand the world around it, and then major advancements in machine learning and deep learning, right? And then combine that with cloud computing, so we can actually have the amount of computation available to us to really learn these, to extract meaning from massive amounts of data, has enabled us to go after this, right? And so it's just, and then the vehicles themselves have become more amenable to automation. There's higher density of electronics on them. They're easier to control than they would have been even a decade ago. So it's this convergence of a lot of technology, and then an increased understanding that the status quo is not acceptable, that we lose 40,000 Americans every year on our roadway. We lose 1.2 million people globally, and this is a major blight on society, and it's something we should be doing something about. And we can make it easier to get around, we can make it easier to and less expensive to move stuff through the world. So this combination of technology advancing and a recognition of the need, I think is leading to this magic at a time.
And Peter, is that a similar picture? I'm guessing there are some similar trends, but it's slightly more recent. We're seeing this real uptick in activity in manipulation and robotics in industry, right, and AI.
Yeah, so I would say like a lot of the trends are extremely similar, and I think probably a little bit of difference on the technology side. I can go to the market side a little bit later, but on the technology side, I think we are a little bit more unapologetically believing in it's mostly machine learning power. Like there's hardware, there's sensor advances, but if you look at those advances, they draw from the same set of technologies. Like if you look at LiDAR, time of flights, like these sensors that we are making amazing strides, but they still draw on pretty much the same set of technologies that have existed for many decades. And to us at Covariant, like what we strongly believe is modern day machine learning, like maybe kind of call it like different variants of deep learnings, is kind of the path that categorically didn't exist. Well, it kind of existed, but it didn't really work. Like now we really had a way to make it work. And really that layer of intelligence is what actually make it work, and is what power like all the amazing advances that we saw in computer vision of how machines can classify images better than human, and how like combining deep learning with reinforcement learning created AlphaGo, where machines can make decisions better than human. Well, albeit in fairly bounded scenarios, but like all of those amazing leaps and bounds forward in intelligence is really mostly driven by modern day machine learning. So I think like to us, we are a little bit more unapologetic about that. Like, I mean, there are obviously other things that need to go along, but really that piece is the most irreplaceable piece. Important, amazing engineering happens at other places, the hardware, the sensors, actuations, and I mean, in self-driving, like regulation and other things that also need to come along with it. Amazing hard work, but like I think the irreplaceable piece, the new piece, is really modern day machine learning. And then the other part that Chris talked about, like also resonates a ton. Like in what we see in the, we are not just focused on logistics, but logistics is a key place, a key first step for us. And what we see there, a big thing is just the boom of e-commerce has just created such a large demand on the logistics backbone. Like when you are in a distribution format, like where goods are routed to tens of thousands of retail stores, and then like people go to retail stores to buy it. That's very different from when you need to ship items to tens of millions of people. Like that's like extremely completely different orders of complexity and difficulties. And that is extremely taxing on the supply chain backbone. And like that has driven up such a demand of innovation as well as labor scarcity. Like everyone that we talk to, every customer that we talk to that's in the warehousing, that's in the logistics industry, like the biggest pain is we cannot find people to do the work. So like even when a lot of people think about robotics automation, they think about robots taking jobs. But in the very, very near term, like what we are seeing is that there are not enough people that want to do those kind of work that are very important for the society to function. It's like in Chris' case, importation, and in our case, like just goods moving around to keep us like, function as a society.
Yeah, I think it's kind of obvious or very alluring that the kind of the business case in each situation, like the importance of safety on the roads, or this huge opportunity in logistics and other areas of sort of manipulation, manual work. But one thing I want to, so you talked about the importance of deep learning and AI, which I think is really, is at the heart of so much stuff that's happening. I think that the point about sensors and hardware is actually very important as well. But with deep learning, with AI, one thing I want to talk about is like edge cases, right? Because especially following autonomous driving, it's been very clear that it's just been difficult to kind of get all these edge cases, all these different. I mean, I think one should point out that autonomous driving is kind of one of the most amazing stories of robotics in its history, right? Because it's literally putting cutting edge robots out in the real world, having to deal with humans, which is just a kind of unthinkable thing to try doing. But it's clearly challenging to try and I mean, it kind of is amazing to do. I mean, that's meant as a compliment, but it's clear that there are these edge cases to deal with. And I know that it's a similar problem in handling goods as well, right? You have to kind of focus on particular areas because there are these, and that can have different consequences. So how are you going about trying to sort of attack? Because I imagine this must be one of the key challenges for both of you. So Chris, I mean, that's, everyone talks about it in self-driving cars, but what are some of the technical approaches you're using for going after that?
Yeah, so part of it is just understanding the kind of what's possible and what's out there. And so we do that by looking at accident analyses and reports and try to understand it. We use internal processes where we kind of do what called hazard analysis, where you're thinking about what can cause there to be failures. We'd use tools like failure modes analysis, where we look at what can break and how we have to mitigate that. And then one of the cool things we've put a lot of effort into is building offline tools, in particular simulation tools, where we can create interesting events and then create numerous variations around those interesting events. So if it's a child running into the road, you may not see that in maybe in a lifetime of driving, but it's clearly an event that matters. And so we can create a simulated child that looks and behaves, runs like a child in the real world. We can generate the sensor data that comes back from them, and then we can create a lot of variations of that child wearing different clothes, that child moving at different speeds, that child moving from different places, and that can at least start to give us confidence that we'll be able to see that child in the world and react to them. And then we can move it to structured outdoor testing at some point, and then ultimately that collection of evidence gives confidence. But I'm confident that Peter has even more thoughtful things to say about this.
Yeah, Peter, the simulation is obviously a key part of what you're doing and the kind of academic work you've done and work at OpenAI. So tell us how that is that sort of central to what you're doing at Covariant.
Yeah, simulation is very essential, and I just want to say, Will, I think this is kind of the crucial question, right? So how well you can handle the long tail edge cases, and how do we even think about it? And first of all, why it matters? It matters because no one wants a robot that works for 10 minutes and then you need to have a person come in and help fix it. And no one wants a car that drives for 10 minutes and then it would pull over and then it requires someone to help it navigate a situation. It's just the level of autonomy is fundamental in this. And like, so now the question is, how do you endow the AI with the ability to handle all of those hard scenarios? And so the great Chris talked about is exactly the same kind of framework that we use to think about it, like really characterizing what can happen and what cannot happen, and really try to simulate as much as possible of what can happen. And so maybe like one thing that would be interesting to think a little bit about why simulation is powerful is simulation gives us a way to deal with combinatorial complexity, right? So like, let's say in driving, you see a toddler, like you see a bicycle. Like maybe we never see these two pieces happen at the same time, or maybe like at one case, a toddler happen, like appear on the scene on the left, in another case appear on the scene on the right. Like maybe when you're driving, after you drive 10 million miles, like maybe you have only seen the toddler happen, like appear on the scene on the left, but well, there's also a good chance that they would appear on the right. And like if you try to use the real world to mine for all of those combinatorial, like all of those different combinations of events, it's extremely difficult. But this is the kind of thing that simulation is great for. Like if you can break down to, there's a set of toddler events, there's a set of bicycle events, and in our case, there's a set of this type of objects that you need to handle. There's another kind of items that you need to pick up. But how can they compose together? How can they happen together? Like if you can harness like first of all, you need to do first principle analysis on what could happen. And that gives you a breakdown of that combinatorial structure. And then now you can use simulation to fully explore that combinatorial space. That gives you the AI to learn from it. So in a lot of ways, it's not even kind of like better AI, it's really better data for AI. So like, it's not about like the AI itself is smarter, but if it has seen more scenarios, you have seen more part of the problem space, then it can learn to be smarter. But I think I'm probably not just speaking for myself here. Like I'm sure Chris will agree. Like this is not a solved problem. Like even though like we believe like this is the route forward. Like I would be kidding if I say like the covariant AI can handle all edge cases now. That's definitely not the case. But this is a strong path to go towards conquering that.
Well, I'm curious if you think besides having more data and simulation as a way to kind of enable that learning, then it might be you feel there might be a need or opportunity for advances, fundamental sort of advances in algorithms and approaches, because it's one thing that's pretty amazing about your companies and about a lot of stuff going on in AI is that things that are literally happening 6 months before could make a significant difference. And so I'm sort of interested in if you're tracking like what's going on. I mean, this is one of the reasons why real AI experts, people coming out of the labs and the institutions that you come out of is in such demand. So yeah, tell us about Peter. You're nodding, so I'm going to go to you first. Are you sort of keeping very close eye on what's happening in the kind of the machine learning, deep learning world?
So a couple of things. We think about the problems in two ways. So the first category is what we call, like in the machine learning technology language, is called generalization. It's like when you put an AI into a scenario that has never seen before, how it would deal with it. And then the other concept that we think about is capacity. Right? So this is if you have operated in this environment and I have given you data for it, can you learn to master it? And the answer is not necessarily always the case. Like for example, we can try to teach a puppy dog how to speak English. Like you can give them all the data, like they might not be very useful. And these two places are where the algorithmic and research advances happen. Like, can you make better model, better algorithms, so that when they see something the first time, they behave better? And can you make models where they have a higher learning capacity, like meaning they have a higher ceiling, like they see a very hard scenario, they can take in the data and learn that. And these are the places where research advances help us and instrumental in success. And so this is kind of like a little bit of, I would say, a very core part of covariant thesis. So I'm actually pretty curious like how Chris would react to this. This is kind of like why we have amazing research scientists like working on those problems, is to allow us to handle the hard scenario, make sure you can learn, and then make sure when you go to a new scenario, you can generalize better. So absolutely, we are tracking the field very closely, but we are also making a ton of our own advances that are kind of quite parallel to the track of how the deep learning field is evolving.
Yeah, I'm just sure, Chris, I'm sure it's a similar picture, right?
Yeah, no, of course. And I think one of the great kind of cultural things about the deep learning movement is that so much of it, even when it's been happening at corporate labs, has been published, right? And I think it kind of came in the way that deep learning moved into industry, that there was a lot of people kind of in academia working on this work, and the only way, and it became clear that it was important, and the only way that companies could entice these folks to come join them was if they, gave them the flexibility to be, publish the work that they were doing. And so we've all, as a community, kind of benefited from that. And yes, we hire great people that, work on really interesting, deep learning problems, and they absolutely are tracking what's published from the academic and other industrial labs as well. So.
Well, we have a really good question here, which is about the sort of the business model, business approach, which I find very interesting, which is what is the bigger opportunities in robotics? Is it going after sort of niche specific application or something more generalized? I mean, the thing is, you both are going after things that are kind of more generalized, but you're looking at certain niches to begin with. So I'm guessing maybe it's a mix of the two. Chris, what do you say to that?
Yeah, so I think for us, it's what's the minimum thing we can get to actually, deliver value in the world, and then expand out from it. Right? I look at the automated vehicle space, and transportation in the U.S. is something like a $3.2 trillion, 3.7, something like that, some insanely large number, right? And a lot of that is on the ground, people and goods moving. And so let's go find the first application so that we can start to demonstrate this and show the safety of it, show the quality of it, show the return, and then we'll expand out from that. And for us, that first application is in trucking. We've invested heavily to be able to go after trucking. We're developing the sensors that are necessary. We looked at the driving application, and we found that that's kind of the right balance. We think that in that space, it turns out the roll of toilet paper in the back of the truck doesn't get frustrated if you take a little longer to make the turn because you're trying to be a little safer. And so we think that's a really interesting way to kind of marry the initial deployment of this technology with kind of the customer demands for it.
Right. And I guess Peter, you also have some ability to sort of go after specific use cases, or would you say that's right?
Yeah, so I would say like Covariant and Aurora are very similar in that regard. Like there's the platform approach, like where we want to build this AI layer for the broad tasks, applications, but we start with very specific application. And then I can like, and since Chris like gave a very good answer like for why you start with a specific one, that's just direct analogy of that in logistics world. There's just like applications where it's ready to go today with straightforward expansion path, and they are the applications where the industry is experiencing a lot of pain points. But maybe let me talk a little bit about the other side. Like why platform? Like why not just do that? Like I mean, why not just solve trucking? And for us, like why not just solve packing orders for warehouses? And the reason for that is, at least for Covariant, when we think about building AI for physical world, you have a very interesting property of amazing generality, because we only have one physical world. Like so, like you have different robots, you might be operating in different environments, you might be seeing things that are slightly different, but ultimately you're still interpreting the world as a 3D world, and it follows the same set of physics. Like these are the kind of amazing grounding that you don't get anywhere else. Like let's say if I want to build an IoT AI company that interpret data stream from refrigerator to HVAC system, well, good luck building a standardized system. Like there's just no common grounding between those kind of systems. Versus like when we build AI for robotics, for physical world, there's this amazing grounding that actually allow you to build a universal AI that work for different kinds of applications. So like, I mean, in Chris' case, trucking, taxi, very different. Like, I mean, the scenarios is very different. But I mean, if you look the degree deeper, like you still need to see the road in 3D, and you still need to like predict where the vehicles are going. In our case, similarly, you still need to see the road in 3D, and you still need to be able to drive different robot arms, and you still need to think about affordances of how you interact with objects. obviously the details is a little bit different, but as you move from one use case to another, what we have been seeing is this super accelerated return. Like once you conquer the first use case and when you expand from it, it's not a linear effort. Like when you go from the first one to the second one, you find that the second one is only 20% additional effort. You find that the third use case is only 10% additional effort. That's because of the strong transfer that comes from the AI that's grounded in the physical world.
Right. Well, so we had a good question from one of the viewers about what your timeline is. I think it's very common to ask people in the self-driving field when they expect to get full autonomy. So I'm going to start by asking Peter, when do you think you'll get robots? I'll give Chris a bit of time to think about that. But when do you think we'll have robots that can manipulate anything as well as a person?
Well, so I think this is the tricky part of the question. So like if you say, when can we get a robot that can manipulate anything as well as a human? Maybe a decade away. But if you say, like, when can we get a robot that manipulate a subset of things as well as human in a more restricted scenarios, then I would say yesterday, like, because like these robots are already working. Like some people around the world, like in Europe, in North America, are getting packages that are handled by covariant robots. And so when we think about this, is like, really think about it, like it comes a little bit back to the platform question. Like you cannot solve everything at once. So you find like more restricted problems where it can allow you to get started, and then it like improve the dexterity, the level of manipulation, the generality of your system over time. And so the general problem is far from being solved. But when can we start using this technology? I would say already happening.
I would say 10 years is still pretty impressive. That would have a big impact, very broad. And Chris, what do you say about full autonomy? I know it's the gospel for everybody in the industry, but you know.
Well, this is great because I get to say, like, it is shocking how similar what Covariant and Aurora is doing, because I think the answer is the same, right? Like, turns out that yesterday, right? Like that if you live in a suburb of Phoenix, you can call a car from the company that I used to help lead, and it'll pick you up, and there's nobody in it, and it'll take you to somewhere else in that suburb, and you get out, right? And that's a subset of the driving domain. You know, if you park at a particular terminal at Heathrow, you can take a shuttle with no driver that drives between two concrete walls and gets you there. You know, we expect that over the next decade, you're going to see a ramp of applications and more of these vehicles operating in more diverse environments. And it's going to take a little while as we learn what we don't understand about the problem, as we generalize it. And as we learn how to build the real business, because while on its surface it seems straightforward that, you know, we're building a driver and it's going to go do the thing that a driver does in the world, that misses that drivers actually do a bunch more, right? Whether it's they're checking the load or whether they're maintaining inventory, and so figuring out exactly how we interface with our partners to support their businesses, I think that's going to take a little while, and it'll be fun when we get to that kind of normal startup phase of trying the product, right? We as a company have to spend the next several years building the core technology that enables us to then go and build the business on top of it.
Right. We're getting a little tight on time, but I want to squeeze in a question about, so one of the questions I think came in from people during registration was about the importance of cloud robotics. And I've been thinking about this a lot, actually, because I've been looking into this much hyped technology 5G. And it's quite interesting that there's some research and some industrial work looking at both robotics and autonomous driving and how those technologies might benefit from something like 5G, which promises these very, very high speeds, but low latency and high reliability. But more generally, you know, that seems like a potentially extremely important shift where you can take computation off the device. And obviously, cloud robotics is already kind of a really hot research area. So yeah, Peter, maybe presumably cloud robotics is something you're already looking at, but how important is that to the future of the company in that field generally? And one other thing is, I wonder if you think about how different types of robots are going to start talking to each other eventually.
Yeah, so there's a ton of aspects embedded in there. So maybe I will break it out a little bit into different chunks. Like so, there's cloud computing as the idea of you have access to massive amount of compute without in any infrastructure. That's obviously extremely important. Like we all know, and as Chris has pointed out, deep learning, modern day machine learning is really driven by compute power. Like if you don't have compute, like there's nothing you can do. And so like cloud definitely enable the kind of autonomous robots that we are building from the perspective of training, like from the perspective of building the AI models. And then there's the second idea that you mentioned, like maybe it's more of cloud plus 5G connected. It's like how much inference, like how much the models like inference capability, like do they happen on the cloud or do they happen locally? I mean, I have to say, from what we see, like we still see most inference happens locally, like meaning the models, the AI, the brain would happen along with the robot or the vehicle. Like that's just because like these are the kind of situations where you need to just make decisions super quick. Like there's not a lot of time for you to transmit to a data center somewhere and then get back. And then I think the last idea that they touch on is cloud as a cloud as in connectivity, like it's about how like these different agents talk to each other. That I think it's happening. Like I think it's definitely a big thing in the more multi-agent space, like where you have multiple robots interacting with each other. But even in our space, like I mean, the robots are connected. They share the same brain. They all upload the experience for the train happening in the cloud, and then the learning gets downloaded to every robot. So like they are really connected through a shared brain. Like so, like the experiences are shared, like kind of the skills that they learn are shared. So that piece is definitely happening, and we are definitely not thinking about isolated machines that operate on their own island.
And yeah, and Chris, you know, it's a different scenario when you're out anywhere in the world, but connectivity is already important for autonomous vehicles, and yeah, I'm wondering what you see for the future there, and whether you know different companies' vehicles should be talking to each other. This idea, which is sort of fallen by the wayside of vehicle-to-vehicle communication, but there's some potential there, right?
Yeah, and I think I would, you know, once again agree with everything Peter just said. I think that the things that I would augment, right, is that one, I think 5G is really interesting, but it will not be truly ubiquitous, right? That if we're driving down the road and we hit a dead spot of coverage for whatever reason, whether it's a power outage or, you know, we're just not where there's a tower, the vehicle is going to have to continue to operate safely. So we expect the inference, kind of the core driving capability to be on board. At the same time, that ability to call home for help where you can afford latency and you're not compromising safety is actually really interesting, because if you can do that, whether it's a person on the back end or whether it's a system that has more computation, you can sort of solve more complicated problems, then you know you can leverage that. You don't have to solve kind of general AI on the vehicle. I think there's really an interesting opportunity with 5G or V2V. Right? The reason why kind of some of the classic V2V, the DSRC, digital short-range communication V2V, is fallen away is because with 5G, you actually get very similar characteristics, and so you could overlay on top of that, and you know, there's the opportunity to share, say, perspectives from different vehicles, you know, and you get into a challenge of trust. Do I believe that data, or is that some, you know, adversary that's trying to create, you know, a dangerous situation? So you have to work through that complexity. But I think if you think of all of that as an overlay, and if you can build the trust, and then it becomes a really interesting overlay as the density of these vehicles gets larger.
Yeah, that's great. And I just realized that was a question. Someone just asked that question in chat, and I didn't even spot it. So I'm glad I asked it. Well, let's talk a bit about how you are coping with COVID, because I mean, it's difficult for all of us. We're on Zoom, and you know, stuck at home most of the time, but most people don't have this kind of need to work with real hardware. So how are you both coping with that? Peter, what's your approach been?
Yeah, so like one aspect is what we talk about, like heavy leverage on simulation. Like it's like what are the things that you can do through simulation, then you do that. And then the other aspect is that we use to cope with this is a little bit geographic diversity. So a lot of our robots developments happen in Europe, in Asia, like in some parts of the world that are less impacted by COVID, or well, are currently less impacted, or were less impacted by COVID. Like that's what allow us to develop this. While like on the US side, most of the core team need to work remotely. And this is one of the benefits of being a AI software layer company. Like it allows the hardware part to happen elsewhere without necessarily being restricted to here.
I see. Where is the team that's not COVID affected? It's are they in China? There seem to be a few, or Taiwan. There are a few places.
Well, so like I mean, a set of our partners are in Europe, and so now they are not doing very well. But like for a while during summer, like things were pretty much back to normal. And we also have team in China that can live a much more normal life, to put it lightly.
Well, and Chris, I think there's been this in some places at least a rule about having two people in a car, and obviously that's poses problems in terms of social distancing, and I think that definitely at the beginning of the sort of outbreak in the US affected autonomous driving. How is that progressing now? How are you coping with this?
Yeah, so most of our people are working from home. We do have surprisingly actually a little more of a hardware content than Peter does, in that we develop sensors and computers, and so we've kind of dramatically reduced the number of people in our offices, of course, and we have people that go in for the minimum amount of time they need to do their work and then leave, right, to try to reduce the amount of mixing. With our vehicle operations team that are out on the road gathering data, we've changed the way we work a little bit. So we've staggered when they depart in the morning, so there isn't kind of a group of them getting together for a meeting beforehand, and we've kind of paired up consistent pairs. So it's one additional person that's now in their circle, but it's just one additional person. They work with that person on a regular basis, and that's the way we try to manage the be responsible in the way we manage that. And we kept a very we moved away from the office a little bit earlier than some. And despite things getting incrementally better for a while this summer, we actually kept the same level of rigor and protocol in place to help to minimize the risk for our people.
Okay, yeah. Well, so one of the other questions, which I think is a very good one, is how do you think robotics, AI, the sort of general technological advance we're seeing right now is going to affect employment? And I know you both have probably very good canned answers about how it's not going to put everybody out of jobs, but I'm looking for just an honest, candid kind of answer, because it's quite difficult to predict, and obviously and to kind of try and extrapolate, and I think it's undoubtedly more complicated than either of the pictures that are sort of often painted. So I'm curious what your guts really tell you. So Chris, what do you think about it?
Yeah, so I am absolutely certain about the long-term social benefits of what we're doing, right? That we can make the road safer, we can make it less expensive to get around, we can increase accessibility, and improve the quality of that. That there is absolutely more demand for transportation mobility than we have people willing to provide transportation mobility. So there's an immense amount of opportunity, and over the long term, in the same way that I think the Industrial Revolution has undeniably improved the quality of life on the planet, that what we're doing in automated vehicles will improve the quality of life on the planet. At the same time, there are people whose job is driving, and we're building a driver. And ultimately, our driver will be better, and it will be safer, and it will be less expensive. And so there's going to be a period of time where those people who do driving jobs today, either they'll retire, we won't have people doing that, or they'll be displaced. And I think it's on us as a society to say that we want the long-term social benefit of this, and then we're going to support the people who are impacted through this transition, right? And I think it's difficult, right? And there isn't an easy answer to it. I think that there's a number of studies that show that whenever you improve the efficiency of the economy, right, which is what we're talking about, that actually increases employment. But that's, again, that's good for us as a whole, but it's difficult for the individual that is being displaced, right? And I think, so that's just tough, right? And these are difficult jobs. They're jobs that generally have lower life expectancy. They have health issues that are associated with them. So again, as a society, it's hard for me to see that this isn't the right thing to do, but that doesn't make it any more difficult for those people that are impacted.
No, that's a great answer.
Or any easier, I should say, for the people who are impacted.
Yeah, no, that's very, makes a lot of sense. Yeah, I mean, Peter, similarly, there are obviously plenty of opportunity for the technology you're developing to displace some people, as well as, especially over the longer term. So what are your thoughts there?
I mean, it's going to sound like copying straight from Chris, even though this is like typically the answer that I give to other people. But maybe let me just like add a little bit nuances. Like, absolutely agree with everything that Chris says. Especially, like, we cannot just dodge the question of labor displacement. Like, that's just not true. Like, this is something that is part of the impact, and we need to acknowledge that, and we need to participate in societal change to cope with that, to help that transition as much as possible. But maybe I can add a little bit to Chris' framework. Like, we think about it in near term, medium term, and long term situation. In the long term picture, fully agree with what Chris is saying there. Like, so we always benefit from more productivity being unlocked, especially being unlocked from repetitive work, being unlocked from things that people get injured from, people that don't want treat as temporary jobs and like switch every 2 weeks. So in the long term, like, we see this as strictly beneficial. And then in the near term, we are working on problems where there's just simply more demand than labor supply. Like, so like, this is, if you look at most of the adopters, like, they are not adopting because they want to save some costs. Like, they're adopting because literally they couldn't find people to do the work. So the near term and long term are very clear. I think the medium term, like, that transition period is where, like, there will be displacement, and it is hard. And I think even though it's better for society as a whole, like, it's going to be hard for some subset of the people. And this is the type of things that we at Covariant would like to be an active voice on, participating in policy, participating on how we can create a change with better broad support to help those people for us to get better. But it's not easy. Like, I don't want to sugarcoat this and say, well, everything is rosy. It's not, like, especially in that medium term period.
Yeah, well, it's not up to you guys to solve it, but I think that's, a very good point, that you can be a voice. It's been surprisingly, well, I guess maybe not surprising, but there's been little discussion of it on the political level in the US. And I think maybe now with a new administration, there'll be sort of more kind of thoughtful discussion of it. But it seems like it's going to be a real issue, especially when there's kind of pushback against tech. For companies that are at the center of this, it's going to be something to be out in front of. So there's one question here which I just love and I want to ask, which is, what is your craziest prediction for the next 10 years? It doesn't specify in technology or robotics, so I guess you could be whatever you like, but you might want to make it more about technology to make it relevant. But there you go. So Chris, yeah, what's your craziest?
Oh, geez. I wanted Peter to go first this time, so I could say what he said. No.
Oh my God.
Craziest thing. I don't know about crazy. I think that, so let me stick to what I know, right? So I think that automated vehicle technology is right now very much in the valley of disillusionment in the Gartner hype cycle, right? That's where, by the way, great job for Gartner branding that. Nice work, gang. But in the hype cycle, right, we're kind of in that valley of disillusionment, and that's going to lead to a massive, like, a number of the companies that are here are just going to fail, right? And it's not because they're not smart, good people. It's because just market conditions. But I think that over the next handful of years, we're going to start to see real successes. And that while we are going to be off by somewhere between 5 and 10 years of kind of where we hoped we would be with this, I think we're going to start to see pretty profound impacts of this, of automated vehicles, right? And start to see people being able to use them in their daily lives in a real way. I think it's going to be incredibly exciting. I don't know if that's crazy or not. Maybe I'm just selling my own Kool-Aid. But, you know, it's, I think it's just an incredible time to do anything with the automotive industry. The combination of, you know, electrification and the transformation that's causing to happen. You combine that with automation, which is really the first change in 100 years that's like fundamentally changing what it means to be in a car, right? Like it's really exciting, and I think it will be in the same way that, you know, the smartphone created whole new businesses. It's going to be just amazing to see how this change in the cost and availability and efficiency of transportation ushers in new interesting businesses, right? And what happens when you can over time drive the cost of moving a vehicle through the world towards zero. Like that's going to be fun.
Okay, great. And Peter, what do you?
Next time, I really need to go first if there's next time, because I think it's also going to sound very similar.
Man, I'm sorry. I offered.
So maybe I would generalize it a little bit and kind of like talk a little bit about autonomy in general. So I think in 10 years, I actually don't think this is crazy prediction. I actually think it will for sure happen with 99.9% probability. I think in 10 years, we will see full realization of what I call autonomy 1.0. So this is like any laborious task that we are doing now. We will see machine powered by AI doing it. So that's for driving, that's for manipulation, that's for a ton of other things that are happening. Like, so basically any task that you name, we will solve it in the next 10 years. And I think what we will start to see is autonomy 2.0. Like it's when movement of physical goods, when the production of physical goods of this physical world become a lot less costly and have a much higher efficiency platform to build on top of, like what are the applications that you can build? Like what is the next revolution that can come? I think we will start to see early signs of it. I don't know exactly what we would look like. And the analogy would be mobile 1.0 is you get a smartphone that can do the same thing that you can do in a PC. But then like mobile 2.0 is the same infrastructure, but then now you get Uber, you get Lyft, you get like all these amazing companies that can be built on top of this platform. I think we would start to see autonomy 2.0 in that time frame. I don't exactly know what it would be, but I think it would be something that's very exciting.
Okay, great. Well, I actually missed one last question, which I think we have time to get into from an anonymous attendee, which I think, you know, Chris, you've already talked about this. The question is, do you worry that your business models will be more difficult because they involve hardware, which you don't make, but you obviously make some of that hardware. So how important is hardware? Like everybody says, when you're doing software, eventually you want to get into hardware. So how critical is that? And that points to some of the issues around, you know, like the modern supply chains where you're going to source technology from. So yeah, how much that is a factor for you? Chris.
Yeah, absolutely, right. And it's, I lament on days, on bad days that we're not building a web app, right? It's not that building a web app isn't hard, but it's easier in many dimensions, right? And so, yeah, the physical supply chain, the fact that there's, you know, a rate on how quickly you can turn stuff out and scale, right? And that can be an advantage and a disadvantage as you think about the business, but you have to take that into account and you know when you know the bets you make on technology become higher stakes because you commit to them further in advance and you have to thus stick to them longer, and if something comes along they can be disrupted. So it's yes, it's incrementally more challenging, and it matters, and it plays into the way we think about the problem for sure.
Okay, great. And Peter, you know, do you worry that you don't make the hardware, or are you developing something so general purpose that it's not so much of a factor?
There's so many ways that this question can go. Like, I mean, there's the whole go-to-market aspect of it. But I would maybe just add a little bit to what Chris is saying on the complexities of building product that involve hardware, or at least needs to integrate with a hardware component of that slow iteration cycles, like more complexity. That's definitely the case. Like, so I think that's just kind of the reality of building AI for the physical world. Maybe I would want to highlight a slightly different piece of it that's probably unintuitive. It also increases the barrier, right? So this is not like you can look at a web app and then you can pretty much figure out how to recreate it. Like, I mean, you have some problems when it hits certain scale, but then like you can find plenty of great engineers in the valley that can solve scale problem for you. But really, when you develop AI software that's so coupled with physical system, like there were so many hidden surprises. There's so much complexities that come at that intersection. And without doing it, like without going through that iterations, you don't even know it. Like you don't even know what to solve for. And so while it is more painful, more challenging, you need to build more holistic team to solve it. You need to build teams that have different competencies to solve it. In our eyes, like they are the kind of the path that you need to go through, and like kind of the people that are further in their journey, like just have a more long-lasting advantage compared to other people that are trying to do the same thing.
Okay, great. Well, I think we're going to wrap it up there. We've gone a bit over time, but I think that's okay. And all that's left to say is thank you very much to Chris and Peter. That was, we have another question. Okay, I'm just going to ask this question. So someone's telling me to stop. Okay. So for each of you, which is the biggest challenge you face and the risk to your business to achieve your ultimate vision? Okay. Which is the biggest risk? That's interesting. Chris, would it be the public perception of the technology by any chance, or?
No, I like, this is going to sound naive, but I think it's technical, right? I think this is just a fundamentally hard problem. I think that the value proposition, if we deliver the technology, is just clear, right? That you know, whether it's I can go to the bar and have 2 drinks and still get a ride home, or I can reduce the cost of moving a thing from A to B. I can have safety on the road. I can have all of these, right? Like anytime we've given people the experience to try this technology in early forms, they get it and they love it, right? And so it's getting there and delivering on that and doing that with urgency while making sure we do it safely as well.
So is that technical challenges in terms of meeting this sort of broader vision. So the edge cases again, is it sort of coming back to that?
Yeah, it's the combination of edge case. Like, yes, like you can basically download software to make a self-driving car drive around a parking lot with nobody in it today.
Right.
But getting it to the point where it is the level of reliability that you really need, that you should be at to deploy this, and not have it be some kind of beta test that's putting people at risk, like out on the road, right? I think that's hard, and it's a schedule and time risk.
Yeah. Okay. And Peter, what about for you? Would it be the similar thing?
Yeah. So maybe I would answer one on the technical side and then one on the go-to-market side. On the technical side, exactly the same thing. Really, the level of autonomy, right? So an AI for robots is only as good as how much it can do for you. Like if it can only drive in parking lot, like, and it breaks down on in a city street, like in our case, you can only pick like pre-positioned boxes versus like anything that you've thrown at it, like that makes the difference. Like the level of autonomy, the level of performance, the level of reliability, that's always the critical risk. And then on the go-to-market side, we're creating a new market. Like, so people are not used to buying robots that learn and improve, and where you place it, like where you design the environment around it. This is new. And so like how a company navigates this new and complex ecosystem, like because it's not just us, the AI provider. There's like the people that build the hardware and people that build the complete systems. How to navigate that is incredibly complex. So like, I think before founding Covariant, I knew that there was a lot of technological innovation that would need to happen to achieve autonomy. But what I didn't know is that you also need a ton of go-to-market innovation to create an ecosystem that work at scale.
Interesting. That's great. Okay, well, that's good. I think it's nicely brought us back to some of the kind of fundamental challenges here and where AI is. So thanks again to Chris and Peter, and thanks for having us all, and thank you for all those questions. Unless someone else sneaks in another one, I think it's time for us to go. So thanks again, guys. It was very fun chatting with you both.
Thanks so much, Will. Thanks, Peter.
Okay.
That was fun.
Yep.
Bye, guys.
Bye.